Okay, so this is the 6.6 part 1 homework video answer key. It's 3 through 13 odd, and I'm going to answer questions 11 and 13 for you. I think that answers 3, 5, 7, and 9, while they're kind of difficult and could be a good start, I'm actually just going to go ahead and give you 11 and 13 because they are pretty representative of even the hardest problems that you would face. 11 has a vertical shift, a phase shift, horizontal stretch factor, or a omega value, a period shift, as well as an amplitude. Number 13 has a negative amplitude, it has an amplitude along with a reflection around the x-axis, and it has a phase shift along with a period shift as well. So you should be able to go back to 3, 5, 7, and 9, given this information, to kind of figure out what you're doing on those as well. But these definitely represent every challenge you would face, as well as, I think, going over the hardest one, and what I would say is probably number 11. So let's just jump into number 11. The book is asking you to find the amplitude, the period, and the phase shift and graph all of these. That's something that you should have done with these anyway. The book could have just said graph these, and I would still just go through and find the amplitude, the period, the phase shift, etc. Those are all things that are important to know when you graph it, and the more you write down, the more likely you are to get this correct. Amplitude here is pretty straightforward. My amplitude is just 3. Actually, before I start saying that, let's again, just to make sure we have it, a times the cosine of omega x minus phi. Now I'm going to say that my amplitude is just that absolute value of a, which is the absolute value of 3, so I'm looking at an amplitude of 3. My period, this is where it gets a little bit difficult. My period is going to be 2. So I'm going to put this as 2 pi over my omega value, which is 2 pi over pi. Those cross out, and I'm looking at a period of 2 radians. And then my phase shift, well, that's going to be that 2 over pi. So my phase shift is 2 over pi to the right because it's minus. Shrink all of this so that way I have space for everything I need to do here. I'm also just going to add in the fact that I'm looking at a vertical shift of 5. I've got a vertical shift of 5 here. Now let's figure out where my period should start and where my period should end. This is going to look really, really ugly, but I still need to go through and write it out just to help me. I'm going to put period start at pi x minus 2 is equal to 0. So I get pi x is equal to 2, and then x will be equal to 2 over pi. And then here, your period will end. This is going to be pi x minus 2 is equal to 2 pi. It's pi x is equal to 2 pi plus 2. So then that x will be equal to 2 pi plus 2 over pi. And where does that even begin to go? Well, we'll start working that out. We'll figure it out. It's not the prettiest. I'm going to do some rough estimations here. I've got 2 divided by 3.14. So what we're going to say there, 2 divided by 3.14, well, this is roughly 0.7 0.64 radians. If you think about the fact that pi over 4 radians is going to be about 0.75, this is going to happen a little bit before 0.65, but we're going to actually scale these by 1, so I'm going to go off these estimations here. 2 pi plus 2, so I'm going to do 2 times 3.14 plus 2, and I'm going to divide that by 3.14, and I'm going to find that this should happen at about 2.64, which is good, because this does represent, this is going to represent a period of 2 pi, which is exactly what I want to see here. So I've got 0.64 radians to about 2.64 radians. I'm going to be doing a lot of rough estimates here. This is not the prettiest. Knowing that I'm going to have to make some rough estimations, I'm going to go ahead and I'm going to scale my x-axis. We're going to scale my x-axis by 1/2 radians. And then I'm still going to scale my y-axis by 1. That's going to work out for me. So now I've got all my information. I've got where my period should start. I got where my period should end. I have the rough areas where they should fall. You should know if you got a graph like this in a class test, this would happen in a calculator section. I'm not expecting you to be able to graph something like this without a calculator. It's really ugly when you put a pi in front as your omega value, because when your pi is an omega value, then you're looking at a pretty odd period, especially then when you throw in just kind of a normal average run-of-the-mill number as your phase shift. This is about as ugly as a graph as the book could ever throw at us. But through some simple estimation, we're going to end up making it work. First thing that I'm going to do is I'm going to put that fake x-axis and I'm going to go up 1, 2, 3, 4, 5 spots and then draw my fake x-axis to represent exactly where this should kind of move to. So this helps me fix my vertical shift problem. I don't have to make a table of values. I don't have to shift all my values up. All I have to know is kind of the general shape and idea of the cosine function and then make my graph based on that. I know that my period is going to start at roughly 0.64 radians. That's okay. That works out for me. So what I'm going to do is I'm going to go up and put a point. This is the cosine function, so that means it has to start above. So I'm going to highlight like right around here. Well, somewhere in that region is going to be 0.64 radians. And then it's going to be 3 above this fake x-axis. I'm going to say that that is about 0.64 radians right there. And then I know that it has to end at 2.64. So I know that I'm at 2.64 based off how I scale this graph is going to end up roughly happening about there. And then a student reached out to me about this last week that one of my graphs, they weren't really sure how to make it work with kind of the scaling that existed. It's going to be hard to make this work, especially with this scaling. Again, this isn't pretty. I'm going to have to kind of estimate where halfway between these is and where the quarter is. Luckily, it's still going by 2. So I'm just going to have to kind of say, like, this is still going to be my 0. Over here is still going to be about 3 below. Up here is still going to be about my 0, and then I'll return back there. And we can see that I kind of still have this period of 2, especially scaling this by 1/2. This is what my cosine function looks like. It does start above. It does go below. I'm going to go through and then just do a copy pasta job here. Drawing this out by hand. I want to see probably 2 to 3 periods minimum. I would specify that on a quiz or a test. But I'm just going to go through now and paste this function over and over. Again, this isn't pretty. It's not perfect. I'm just kind of making do given the fact that I can make some general estimates here. And I'll stop there. I think that's good enough. I've shown you enough periods. So that one is by far one of the uglier ones. I really have to go through and make some estimations on what my starting radian would be, since I'm basing this in whole numbers. Not ideal, not perfect, but I can get it done. It works out at the end. I'm fairly happy with this. I would not give you a problem this ugly on a test without giving you a calculator. This is really something that really doing this by hand I think is kind of outdated, but knowing how to do it still works. So there you go. It's by far, I would say, probably the hardest one on your homework. I'm going to look at number 13 now. This one's a little bit more straightforward. The thing that is tricky about it is I've got two negatives here. So I'm just going to have to start dealing with that as it is. My amplitude here is the absolute value of -3, so my amplitude is still 3. My period, yes, I have a -2, but like having a negative period doesn't really make sense. So I'm just going to write out my period to be 2 pi over 2 here. And so my period is going to be pi. To say my period is negative pi versus positive pi doesn't really have a huge impact on this graph in any way, shape, or form. To say that you move negative pi radians to repeat is the exact same thing as saying I move positive pi radians to repeat, so I don't really need to think about that too much. I do have to account for the fact that I'm going to kind of factor out this -2. So what this would actually look like, I'll show you this. Because my phase shift is going to shift because of this, I'm going to have -2 times x minus pi over 4. So as opposed to thinking about my phase shift right now as putting it over the negative value to think about all of it, I'm going to factor the negative value out and divide by that -2. So then I can say that my phase shift is pi over 4, and that's going to be to the right. Because after I factored out that -2, I still have that negative up here. So since I have that negative up here, that means it's a pi over 4 phase shift to the right. And we're going to see that a little bit easier when I do this. So now let's go ahead and look at where my period should start and where my period should end. So my period should start at -2x plus pi over 2 is equal to 0. I get -2x is equal to negative pi over 2. I divide out that -2 and I get x is equal to positive pi over 4. So that is a phase shift of pi over 4 to the right. See, that works out for me. So I thought about this a little bit differently for my phase shift. So as opposed to just putting phi over my omega, I thought about the fact that let me just factor out that -2, kind of like we did back in September when we were looking at those horizontal shifts when we had a horizontal stretch factor. I didn't really show you this in the notes, but each problem kind of varies how we're going to approach this. I didn't have anything like this in the notes. That was pretty ugly, so I just had to deal with it. I'm also going to do my period end now. So my period will end at -2x plus pi over 2 is equal to 2 pi. Remember, I just take whatever is inside. Doesn't matter if it's plus or minus. I'm just going to take what's inside that sine function and set it equal to 2 pi. -2x is equal to 3 pi over 2. I'll divide by that -2. So x would be equal to -3 pi okay, so dividing by -2, x is equal to 3 pi over 2 times 1 over -2. So then I end up with x is equal to -3 pi over 4. And this is where it gets a little bit complicated to think about, because I'm thinking about the fact that it's starting at positive pi over 4 and ending at negative 3 pi over 4. Again, I wrote out my period as pi, and I said not to think about it as negative pi. But if I want to go back and think about it as negative pi, I move negative pi radians here. So if I start at pi over 4 and then I move down here, this would be negative pi radians. And again, that still is a period of pi radians. We're just thinking about now moving it backwards as opposed to moving it forwards. It's kind of a different concept, but we can still do that. I don't have any vertical shift here, which does make my life easy. So I'm going to still count this by ones. And then why not? Let's go ahead and do by pi over 4s for our x's. So I have this pi over 4 point as my starting, and then I'm going to have this negative 3 pi over 4 point as my end. I set these as pi over 4 so that way it would be nice for me, especially knowing my period is pi, that I can go through and put my values where I need to put them. I'm moving in the reverse direction here. I've got a flip of negative 3, so it should be reflected over the x-axis. So I'm going to end up with something that looks a little bit like this. Not the prettiest function. I have to consider the fact that I've reflected it over my x-axis. So as I move backwards, as I start my period, I've got to go down 3 before I go up. And then as I move forward, it would still be up, back down, down, up. So now I can kind of draw my sinusoidal wave between these points. By far the most complicated thing here. Again, now I can kind of go through and copy and paste this. And again, not perfect, but it works out. This is exactly what it should be. It's kind of an ugly graph. I understand that it's an ugly graph, but works out. A lot of things to think about. Again, questions 4, or question 3, question 5, question 7, and not so much question 9, but question 3, 5, and 7 are definitely, you can kind of explain them based on the notes. 9 can be explained a lot by how I've done number 11, and then 13 is also difficult in its own right. So I've answered the 2 most difficult questions for you. You should easily be able to kind of do 3, 5, and 7 based off the notes, or you can use the examples from the notes to reference those. Number 9, I would reference number 11 from this video answer key to help you out. And again, if you have any more questions, feel free to reach out. Thank you, and have a great